Have you ever looked up at the night sky and spotted a neat train of lights moving silently overhead? It might seem like a UFO or secret spacecraft, but chances are it's one of Elon Musk's Starlink internet satellites. These SpaceX satellites, over 7,000 strong by early 2025, beam internet to Earth. Yet now astronomers have found that this vast megaconstellation has uncovered a baffling, impossible signal of its own. In a discovery straight out of science fiction, Starlink satellites were found broadcasting radio signals in a band that should be completely silent for space observations. What could explain signals in a forbidden frequency range? And why is it a big deal for science? Let's dive in and unravel this cosmic mystery. Still, this amazing network appears to have uncovered a cosmic glitch. Researchers examining radio telescope data noticed that many Starlink satellites were leaking unexpected radio waves into a frequency range reserved for astronomers. In other words, these satellites were whispering on a channel that was meant to be completely quiet, a whisper that shouldn't exist according to the rules of radio astronomy. Starlink is SpaceX's ambitious satellite internet project. It's a huge constellation, thousands of small satellites orbiting about 340 miles above Earth to deliver high-speed internet around the globe. In fact, as of early 2025, over 7,000 Starlink satellites have been launched, making it the largest satellite network in history. These satellites are often seen as a glowing train of dots moving across the sky at dusk, earning nicknames like Pearls of the Night Sky. SpaceX is still launching many more, planning up to 12,000 or more. With so many satellites up there, astronomers have long worried about how these networks might affect space observations, especially sensitive radio telescopes. The mystery signal was detected by teams using powerful radio arrays on Earth. In Australia, Curtin University astronomers analyzed a prototype station of the Future Square Kilometre Array (SKA) radio telescope. They sifted through 76 million radio telescope images, a huge data set, looking for satellite interference. What they found was astonishing. Over 112,000 bursts of radio noise from 1,806 Starlink satellites in their observations. Many of these were harmless, but crucially, 703 of those satellites were transmitting at to 150.8 megahertz, a range reserved for astronomy. In other words, hundreds of Starlinks were lighting up a red zone of frequencies that should have been silent. As study-led Dylan Grigg put it, some satellites were detected emitting in bands where no signals are supposed to be present at all. For context, radio astronomers rely on these quiet bands to pick up incredibly faint signals from the cosmos, such as the hydrogen echo from the first stars in the early universe. One protected band is 150.05153 megahertz, set aside by the International Telecommunication Union, ITU, specifically for radio astronomy. Detecting any man-made transmission in that band is a red flag. Yet the telescope data showed it was happening repeatedly with Starlink. It's like hearing static on a radio in a frequency that was supposed to be off-limits. As astronomer Stephen Tingay notes, ITU rules focus on intentional transmissions and do not cover this type of unintended emission. So until now, no one expected signals in those protected bands. It helps to know what radio astronomers do. They tune their telescopes to catch faint waves from space, like the 21-centimeter hydrogen line from the cosmic dawn, signals so weak that even a phone on the moon would outshine them. Sensitive instruments, like LOFAR in Europe, or ska-low in Australia, keep the frequencies around 100–200 megahertz as radio quiet zones. The team at Curtin University observed 68 Starlink satellites passing overhead with the LOFAR array. To their surprise, 47 of those satellites were leaking radio energy in the 110–188 megahertz range. That range includes the 150–153 megahertz band marked for astronomy. In simple terms, the satellite's electronics were unintentionally broadcasting like a hidden radio station. Another recent survey, also by the Curtin Group of ska-low data, confirmed it. Millions of pixelated radio snapshots showed trails of interference from Starlinks. As one report summarized, an increasing number of satellites are being detected, transmitting unintended electromagnetic radiation, UEMR, outside their designated frequencies, and sometimes at these protected frequencies. In practice, this means that while the satellites obey their licensed channels, they create a little bit of noise on the side that radio telescopes can pick up. Think of it this way. Radio astronomers are trying to hear whispers across the universe, faint radio waves from the earliest galaxies, pulsars, or possibly even techno-signatures of alien life. These signals can be billions of years old and unbelievably weak. The bands around 100–200 megahertz are especially prized for hunting the 21-centimeter hydrogen signal from the cosmic dawn when the first stars lit up. But now Starlink is inadvertently turning up the volume on background static. In the worst case, tons of satellites could drown out the cosmic radio whisper with their unintended hiss. Astronomers note that observing the cosmic dawn requires tuning into frequencies below to 150 megahertz. If satellites leak in those bands, it's like someone blaring static right in the telescope's ear. In fact, studies warn that if unchecked, this leakage could block observations that go back to the epoch of reionization, about 1 billion years after the Big Bang. That's when the universe's first stars and galaxies were taking shape. The problem isn't illegal yet. Current ITU rules protect radio astronomy by policing intentional broadcasts, but these leaks are unintentional. As Tingay's team emphasized, 3.7% of the ska band is protected by regulation, but clearly more may be needed. In short, even minuscule signals from thousands of satellites can add up. One study found Starlinks blinking at 137.5 megahertz and 159.4 megahertz, the exact same frequencies used to map the early universe. The Max Planck Institute adds perspective. A radio telescope can perceive a phone on the moon as bright as a distant supernova. So even a microwatts level leak from a satellite, million times weaker than your phone, is comparable to the cosmic radio glow a telescope would normally see. That means our own tech is literally overshadowing the sky we're trying to study. So why are the satellites talking at all? It turns out to be a byproduct of their onboard electronics. Each Starlink carries hardware, processors, power systems, transponders, and these can emit tiny radio signals as a side effect called electromagnetic leakage. The LOFAR team confirmed this in 2023. By watching 68 satellites, they detected unintended electromagnetic radiation from the satellite's electronics. These emissions are not the actual internet signal beams. They're stray noise from circuits and components. Consider the analogy of a microwave oven. Even when not actively running, a tiny amount of RF energy might leak out. For Starlink, that leakage is extremely small, mere microwatts, but our telescopes are incredibly sensitive. Studies note that the leaked power is up to 1 million times weaker than a cell phone. Yet because the satellites are so close, the telescopes still pick them up as if they were strong radio sources. It's a subtle effect, but with thousands of satellites, the collective noise can become a problem. This discovery has significant ripple effects for astronomy. Faint cosmic signals at risk. Experiments targeting the 21-centimeter hydrogen line, looking for the cosmic dawn or dark ages of the universe, often operate in the same 100–200 MHz range. Unintended satellite emissions could mask these faint whispers, making it harder to study the first stars and galaxies. Need for new policies. Since existing rules didn't anticipate this scenario, astronomers argue for updated regulations. This might mean stricter limits on satellite leakage or dedicated mitigation strategies. As one study put it, the absence of clear regulation that protects the radio astronomy bands from unintended radiation is worrying for future surveys. Global consequences. Starlink isn't the only one. Other companies, Amazon's Kuiper, OneWeb, and more plan thousands of satellites too. If they also leak signals, radio telescopes worldwide, especially large arrays like the SKA, Hera, and LOFAR, could see their data contaminated. The situation is already being taken seriously. Researchers and SpaceX are talking. SpaceX spokespersons say the company is cooperating with astronomers. In fact, Starlink engineers have begun modifying future satellite designs to reduce leakage. For example, turning off data transmissions when flying over observatories is one measure. Others might include better shielding of electronics. The hope is that with collaboration, we can have both global internet and clear skies. As one researcher noted, SpaceX has significant progress liaising with astronomers in the optical realm, and they aim to do the same for radio. Astronomers hunt for ancient signals at 100–200 MHz. These bands are often protected to catch cosmic radio waves from the early universe. Starlink satellites have been found emitting in these bands. In one analysis, about 703 satellites were active at 150.8 MHz, a band meant to be silent. Another study found 47 out of 68 satellites leaking energy across 110–188 MHz. The cause is unintended electronic leakage. Tiny signals from the satellite's hardware, not the main data beams, are spilling into adjacent frequencies. Impacts could include masking the cosmic dawn. If unresolved, these leaks could hinder projects like SKA, LOFAR, or Hera that aim to map signals from the first stars. Collaboration is underway. SpaceX is already tweaking its next-generation satellites, and astronomers are working to adapt filters and policies. The goal is to protect the night sky without pulling the plug on satellite internet. This is a reminder that technological progress sometimes has unintended side effects. We still rely on advanced instruments to explore the cosmos, but those instruments are now sharing the radio spectrum with us humans in space. It may call for international discussions and creative engineering. Space agencies, satellite companies, and scientists will need to coordinate, designing satellites with lower leakage, scheduling observations around known satellite passes, or building new quiet zones in space. But for now, one thing is clear. The universe hasn't yet revealed aliens or secret physics through Starlink. Instead, this case reveals the ingenuity of science in detecting even the faintest anomalies. The signal that shouldn't exist turned out to be our own technology, speaking a language scientists can interpret. As we push further into space, lessons like this help ensure that science and tech can coexist. What do you think? Is the expanding skyward of thousands of satellites worth the trade-off? Should there be stricter limits on satellite emissions to protect astronomy? Let us know in the comments below. We always want to hear your thoughts. If you enjoyed this dive into space-age science, give us a like and subscribe for more updates on cosmic mysteries and the tech shaping our future. Thanks for watching, and see you next time under the starry sky.